Leetcode time. Let's solve gas station. So you basically have a list of gas stations in a list wherein in each gas station you would know how much gas that you can get. And this will assume that you would take all the gas in that gas station, right? And then you're also given another list that's related to the gas station. So this is basically the cost or the gas consumption per if you want to go to the next gas station, right? So at first, I think that like this is a two pointer slow fast, but no, totally wrong. But it's kind of like a two pointer too, right? Um, so this is the example here, right? The happy path is if you start at index 3, which is 4, and the starting point is you don't consume anything, you gassed up, right? You get 4. And if you want to go to the next station, right, then you first consume, which is this one, consume one gas, and now you gas up again. Then you consume a gas to gas up again, consume a gas, sorry, consume a gas, gassed up again, and then consume a gas, gas up again. And your remaining is now 5, right? So if you now go to here and before gassing up, you have to spend 5, right? And it goes to 0, meaning you can complete this journey, right? So we're talking about now gas and the consumption. So right off the bat, you'd think that if you don't have enough gas, then you should stop right away. So those are the things that you have to take note. So the context kind of took a while for me to really. I mean, I understand, but like it took me some time to change the variable names, refactor, extract method, in the sense that with me struggling to add variable names, even though some of it is not really necessary, or method, it means that I was thinking so hard of like each of the components or things that would represent the real world, right? We'll talk more about that later, right? So the intuition already mentioned. Approach, one additional goal for me is for other developers to understand the code without any context of the problem. So hopefully when they see it, I understand what this is for, right? But for the approach now to the problem itself, we first get the sum of each array and check is total gas is sufficient from total cost, meaning you have more or equal gas than the cost, right? But if that's false, then um, we can iterate both at the same time, right? And then if current gas is negative, it's missing more stuff, then don't proceed, right? And find the next gas station. Well, a little bit wordy, still confusing. Maybe I didn't say this properly, so I'll change that approach. Maybe quickly do an edit here. If current gas is negative, then this is not the starting gas station. Okay, hopefully that helps a little bit. So complexity, it's often you sort the other array, and then one pass on both of them at the same time. It's still often. O of 1 because no additional space was created. Okay, so now on to the solution, right? So this is the function, right? Um, they pass the two arrays, right? And I pass this to, I call this my validator, right? Um, this is to check, do I have enough gas for the whole trip to complete a trip, right? It doesn't matter where I would start for now. I just want to know, is the available gas in this gas station even possible to make any sort of one whole trip, right? So if you check the function here, it's just basically summing up. I'm using the streams Java 8 API. I have to do arrays.stream because it's a primitive, not an object that I can just call object.stream, right? So array stream, pass that integer array, and then, or int array, sorry, and then sum it up. Same with here. So that's why now I want to add really a context here. So the sum of all the gases that I can take in the gas station is the total gas I can fill up, right? Fill up. And then the next is the cost to make the journey, right? In each of those gas station. So I made the word to have a total gas consumption, right? Because you can that's the word you usually use if you use gas, right? So this is just a boolean to see if gas filled up is greater than or equal, right? Then return true. But we want to check if it's not enough, so we invert that, right? It's better to have that instead of to confuse that the word of don't have enough for a whole trip, right? Then you get confused with the true and false. Always have a true value that you want, right? A positive one instead of a negative, and then just negate it. Okay, so if it's not enough, return -1. Next. So the next function is really we want to find the starting gas station, right? So we pass these two in array again and get the length. And this took a while for me, but uh could be shorter, but this makes sense because we want to know not the so the question is, how do you find the starting gas station? You'd basically have to know which is the first reachable gas station, meaning you have enough gas to reach there, meaning gas is greater than or equal to the gas to consume, and not the other way around. This is a holder to see what my current gas tank is while I'm traveling that journey, right? If I start from something and I want to keep continuing, this is going to catch it, right? It can add when I see a gas station and fill up, it can go down if I consume because of the travel. And now this is the for loop, right? If this is also a variable naming for me, so in this gas station, and to reach that, that's basically the amount of gas in the station, right? I mean, I think I could word this better, but what I mean by this is the gas that I would have if I filled up and traveled to that gas station, right? Maybe I'll word this better right now. It should be amount of gas in this station is only this one, right? But we also want the consumption. So how are we gonna name this? Amount of gas. Uh, amount of gas when okay. Amount of gas when okay. This is kind of hard now to name. Amount of gas filled after traveling. Too wordy, too wordy, too wordy. After travel. Okay, I think I know. I can say gas after filling up and travel. maybe this is better. Okay, let's do that for now. So it means that this is my gas after filling up in the station, to the station, to the station. Okay, let's do this wordy name for now. Gas after filling up and traveling to this station. Gas. Okay, don't worry. We'll word this better. But for now, at least this really makes sense, right? And the gas after filling up and traveling to the station, you add that to your current gas tank. And now I have another validation here to check if the gas tank is empty. Because I want to save the people from understanding this less equals, right? Whatever. So essentially, I'm just going to pass it and check if the gas tank is less than zero. And here the idea is I also think about, let's say, this is what you're seeing in your odometer, things like that, right? You don't really see symbols. You just see. I mean, sorry, you just you would know that its gas tank is empty just by looking at it, and that's kind of the idea, right? So if the gas tank is empty, meaning this is not the station, so we want to see now if the next station, I plus one, is the first reachable gas station, right? And then let's start our journey again. That's why current gas tank is equals to zero. And maybe we want to say restart journey here and this one to properly name and understand. And then return to our first reachable gas station. So that's it. Too wordy, but I like it. Very interesting problem because like there's a lot of this context. If you just code it right away with, let's say, I'll just check this. I don't know who this is now, right? If it's like this, see, it's easy to. I mean, he added comments here just for the sake of adding and explaining too. My goal is to not do this because comments are not really maintainable. Uh, this is just from my opinion from in the workplace. Usually you can add a little bit of comment, but not everything, right? So I'm not sure why we do that all the time in uh, in school, but it's actually an anti-pattern, right? So that's about it, and thank you for listening.